Hi guys, happy Thursday. So right now we would like to solve number 21, which it says cosecant of 83. Now we cannot use anymore the unit circle because it's not one of the angles that the unit circle provides. So that means that we have to use the calculator, right? So again, remember the reciprocal. So it asks cosecant of 83. Cosecant is the same as 1 over sine. So what we're going to do is this is the same as 1 over sine of 83, right? So now we take the calculator and we write, well, first we have to make sure we are in degrees because this is degrees. So let's look mode degrees, that's correct. And now that we are in degrees, we have to do, we said sine of 83, or we can just write directly 1 over sine of 83. We can just write it directly. So it's 1.00 1.0075, right? That's it. So that's how we do it. Okay, it's not difficult at all. Okay, it's just some calculator use. And then number 27, I'm going to do also number 27 and 29 because these ones are more challenging. Okay, so we have sine for number 27. We have sine, they're asking sine of theta when we have cosine of theta equals 4 over 5, right? So to do these ones, we have to know this identities, the Pythagorean identities. So the relationship between the sine and the cosine, it's the Pythagorean theorem, where sine squared plus cosine squared has to be equal to 1. That's actually what we have seen already in the unit circle, right? So we know that sine squared plus cosine squared must be 1. Okay, how much is cosine of theta? It's 4 over 5, so that's going to be 4 over 5 square. Be careful with that. Plus sine square equals 1. Okay, now this is going to be 4 times 4, right? 4 square, because this is going to be 4 square over 5 square equals 1. Sine square of theta plus, okay, now that's actually 16 over 25 equals 1 plus sine squared theta, right? Now, next step, this goes to the other side, subtracting, right? It's like subtracting both sides over subtracting minus 16 over 25. That's what we're doing both sides. And then what we get is sine square of theta equals 1 minus 16 over 25, right? Next step, this one, we can convert this, as we have to subtract these fractions, we need to have 25 on the denominator for both. So the way of doing that, we have to know that actually 1 is the same as 25 over 25, because 25 over 25 is 1. So we're going to substitute this 25 over 25 where we see in 1. So we have sine square of theta equals 25 over 25 minus 16 over 25. And that's 9, right? So we have sine square of theta equals 9 over 25. And now, last thing we're gonna do is we're gonna do square root both sides. When we do square root both sides, what happens here? Square root here. We have to add plus minus, and we have sine square sine of theta equals plus minus square root of 9 over 25. And this is the same as plus minus square root of 9 over square root of 25 because of the power rules, and this is plus minus 3 over 5. Okay? And now we have to think a little bit. Okay? We have to think. You can use an online unit circle, or you can use, actually, let's going to use this unit circle here because, okay, to try to figure out this angle, I want to show you something. So we have that cosine of theta equals 4 over 5, and we have that sine of theta plus minus 3 over 5, right? So I want to show you, and this may be a little bit difficult for some students. Maybe just a second. I'm gonna look for a phone, and I'm gonna show you something on a phone. Yeah. So now I have the phone, and I wanted to show you in this interactive unit circle. I want you to look at when is the sign, which is up here, when it's positive and when it's negative. And if you look here at this green line, here it's positive, right? That's the sign. And if we move, you see that this green line is positive. Sign is positive all the way. While when we go past 180, this line starts being negative, right? And it's negative all the way. So for the sine, it's positive when it's up. It's negative when it's down. While for the cosine, that's the sine, okay? While for the cosine, let's look at it. For the cosine, which is this blue line, it's for the right. Look, for the right, when I move it, for the right, it's positive. But when we go to the left, that's being negative. So all these, so second and third quadrants are negative, while first and fourth are positive. So it's positive, positive, negative, negative. Okay? So you can also see it here, but in the unit circle it's more difficult to see. That's why I brought this phone. Now then, what we have here is that the cosine is positive. If the cosine is positive, that means that the solution must either be in here or in here. While the sine here, it says it can be negative, so it's here or here. So which angles have a cosine that it's 4 over 5 and a sine that can be positive or negative? So now what we need is to take a calculator. We need to take a calculator and we need to find out. So let's try it. Take the calculator and we do arc, right? This is arc cosine of 4 over 5, right? So it's the inverse oh my god, I'm sorry here. Now, so we have inverse cosine of 4 over 5. And what we get is 36.86 because of the symmetry of the cosine. Oh, sorry, but they're not asking us. I'm sorry, they're not asking us the angle. They're just asking on the sine, so that with this would be enough. I'm sorry about it. But if we still want to find what's the angle, we have to do the arc cosine, and then because of the symmetry, this angle can also be negative. Cosine of negative 36.86 still be the same, because cosine, it's an odd function. Okay, now if we do if we take this 36 and we do sine of 36.86, okay, that's going to give us almost 0.6, which is the 3/5. And now if we take this, it's going to be positive 3/5. We take this sine of negative, this is going to be negative 3/5. Let's try it. So if we do sine, because is an even function, negative 36.86, what we're gonna get is the same thing but negative. So that's it. So both are solutions. So that's it. These are the both solutions between 0 and 360. Okay, but again, with this was enough because they are asking only the sine of theta. Okay, now for number 29, number 29, it's even a little bit more difficult. For number 31, before we go to 29, for number 31, look at this. Here you have secant and tangent. You can use this identity here for number 31, right? So for number 28, sine and tangent. What is relating sine and tangent? Again, you need to find for number 28. Let's look at it. Sorry, because you don't see it, right? So again, for number 31, secant and tangent, okay? Secant and tangent, and then for number 28, they give us the tangent, right? You have to remember that tangent is equals sine over cosine, and then we can from there we can find the sine. Okay, let's do number 29. Let's do number 29 first. So number 29, it says they give us cosine, right? They give us cosine of theta, which is 3/5, and they ask us cotangent of theta. That's 1/tangent of theta, right? So if I have the cosine, I can find the sine, right? Because cosine square of theta plus sine square of theta equals 1, right? So I'm gonna put this in here. So that's 3 square over 5 square plus sine square of theta equals 1. That's 9/25 plus sine square of theta equals 1. I'm doing the same thing as I did before. That's why I'm rushing. So sine square of theta, it's 1 minus 9/25. Then sine square of theta is 25/25 minus 9/25. This is 16/25. Then when I do the square root both sides, I do sine of theta equals plus minus the square root of 16/25, which is plus minus square root of 16 over square root of 25, which is 4 plus minus 4/5, right? So and then when I have this, okay, when I have cosine of theta is 3/5 and sine of theta is plus minus 4/5, I know that the tangent of theta must be sine of theta over cosine of theta, right? So because the sine is plus minus 4/5 and the cosine is 3/5, the 5's just cancel out and I have plus minus 4/3. Okay, so again, I'm trying to look for cotangent, but we know that cotangent of theta equals 1 over tangent of theta, correct? So that's going to be plus minus 3 over 4, because it's the reciprocal. Just have to do the reciprocal, okay? And that's it. I'm done. Okay, guys, I think that's enough. As you can see, it's just a game of finding one thing and the other until you get the right answer, okay? Have a great day. Bye-bye.